This is SpaceTime Series 27, Episode 48, for broadcast on the 19th of April 2024. Coming up on SpaceTime, the most detailed view ever of the expanding universe. The Solar Observatory spacecraft Soho discovers its 5,000th comet, and Soyuz returns to Russia with love. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have released their first-year data from DESI, the Dark Energy Spectroscopic Instrument survey, providing the most detailed view ever of the expanding universe. The 5-year study is creating a three-dimensional map of the universe, charting how dark energy is changing over time. Dark energy is a mysterious force, which is causing the expansion rate of the universe to accelerate out from the Big Bang 13.8 billion years ago. Exactly how fast that acceleration gets will determine the ultimate fate of the universe. If the acceleration slows down enough for gravity to take hold, the cosmos might enter a steady state, similar to the way it looks now. But if the dark energy acceleration continues to expand the universe at the same rate it is now, then gradually over trillions of years, all the galaxies in the sky will move away from each other, ultimately disappearing forever beyond the cosmic horizon. That'll make the universe seem like a cold, dark place, with us alone. It's what astronomers call the Big Freeze scenario. However, if dark energy continues to accelerate the expansion of the universe at an ever-increasing rate, then it wouldn't just be galaxies moving away from each other. Theoretically, dark energy could push star systems out of galaxies, planets away from their host stars, and ultimately, taken to its maximum extent, it could even rip atoms apart, and finally tear the quarks and gluons out from the protons and neutrons inside those atoms. That's a scenario astronomers refer to as the Big Rip. And the thing is, if the ultimate fate of the universe is a Big Rip, it'll happen much quicker than the Big Freeze, maybe in as little as just a few billion years from now. So the key to knowing our ultimate fate and that of the universe is understanding exactly what dark energy is doing. Using spectra from nearby galaxies and distant quasars, astronomers are reporting that they've been able to measure the expansion history of the universe with the highest precision ever obtained, providing an unprecedented look at the nature of dark energy and its effects on the cosmic web, the voids and their surrounding filaments and connecting nodes, which make up the large-scale structure of the universe. Since beginning the survey in 2021, DESI has observed a new set of 5,000 galaxies every 20 minutes, totaling more than 100,000 galaxies per night. This has allowed astronomers to map the universe's expansion history over the last 11 billion years with a precision rate better than 1%. And the measurements confirm the basics of our best model of the universe are correct. But they've also uncovered some tantalizing areas to explore which need more data. These include hints that while dark energy began dominating over gravity some 6 billion years ago, causing the expansion of the universe to accelerate at an ever-increasing rate, that may be starting to slow down. They're not sure, but there are some signs which are indicating that. To map the cosmos, DESI collects light from millions of galaxies across more than a third of the entire sky. By breaking down the light from each galaxy into its spectrum of colours, DESI can determine how much of this light's been redshifted, that is, stretched to longer wavelengths due to the expansion of the universe during the billions of years those photons have travelled before finally reaching Earth. In general, the higher the redshift, the further away a galaxy is. Equipped with some 5,000 tiny robotic eyes, DESI is able to perform this measurement at an unprecedented rate. As we mentioned earlier, DESI's first-year data has allowed astronomers to measure the expansion rate of the universe out to 11 billion years in the past, a time when the universe was only a quarter of its current age. An important part of those measurements involves a large-scale structure in the universe known as baryonic acoustic oscillations. Baryonic acoustic oscillations are regular overdensities of matter in the early universe. They're caused by the imprint of pressure waves that permeated the early cosmos when it was nothing more than a hot soup of subatomic particles, a quark-gluon plasma. As the universe expanded and cooled, these waves stagnated, eventually freezing the ripples in place, which provided the seeds for future galaxies to form in greater numbers in the denser areas. The pattern resembles the rippling surface of a pond after a handful of pebbles are tossed in, and it can be seen in DESI's detailed map of the universe, showing strands of galaxies clustered together, separated by voids where there are fewer objects. But at a certain distance, the baryonic acoustic oscillation pattern becomes too faint to detect using typical galaxies. So instead, astronomers look at the shadow of the pattern as it's backlit by extremely distant bright galactic cores known as quasars. Quasars are caused by matter being eaten by supermassive black holes. Prior to disappearing forever beyond the event horizon of the black hole, this matter is being ripped apart at the subatomic level on an accretion disk, in the process releasing huge amounts of energy. Some of that energy is then focused by powerful magnetic fields shooting out as jets perpendicular to the black hole's accretion disk, and we see these, depending on the angle, as quasars, blazars, and active galactic nuclei. As the quasar's light travels across the cosmos, it gets absorbed by intergalactic clouds of gas. That allows astronomers to map the pockets of the denser matter. Now, to implement the technique, researchers used some 450,000 quasars. That's the largest set ever collected for this type of study. With DESI's unique ability to map millions of objects both near and far, the baryon acoustic oscillation pattern could then be used as a cosmic distance marker. By mapping nearby galaxies and distant quasars, astronomers have been able to measure the spread of the ripples across several different periods of cosmic history, allowing them to see how dark energy stretched the scale over time. DESI's director Michael Levy says so far the data is showing basic agreement with our best models of the universe. But he says we're also seeing potentially interesting differences that could indicate that dark energy is evolving with time. While the expansion history of the universe may be more complex than previously imagined, confirmation of this must await the completion of the DESI project. By the end of its 5-year survey, DESI plans to have mapped over 3 million quasars and some 37 million galaxies. As more data becomes available, astronomers will be able to further improve their results, and needless to say, we'll keep you informed. This is SpaceTime. Still to come, the Soho Solar and Heliospheric Observatory spacecraft detects its 5,000th comet, and the Soyuz MS-24 capsule returns to Russia with love. All that and more still to come on SpaceTime. On March the 25th, 2024, a citizen scientist in the Czech Republic spotted a comet in an image from the Soho Solar and Heliospheric Observatory spacecraft, which is now being confirmed as the 5,000th sun-grazing comet discovery. The feat's even more remarkable because Soho was never designed to be a comet hunter. The probe was launched in December 1995 as a joint project by NASA and the European Space Agency to study the Sun and the dynamics of its outer atmosphere, the corona. One of the instruments aboard the spacecraft, called the Large Angle Spectrometric Chronograph, or LASCO, uses an artificial disk to block out the blinding glare of the Sun, allowing scientists to study the corona and the environment immediately surrounding our local star. But over the intervening 28 years or so, LASCO has allowed Soho to do something many other spacecraft can't. It's allowed it to see comets flying close to the Sun, objects known as sun-grazing comets or sun-grazers. Now, many of these comets only brighten when they're really close to the Sun, too close to be detected by other observatories, and would therefore otherwise go undetected, lost in the Sun's bright glare. While scientists always expected Soho to find some comets serendipitously during its mission, the spacecraft's ability to spot them has now made it the most prolific comet finder in history, discovering more than half of all comets known today. In fact, soon after Soho was launched, people around the world began spotting so many comets in its images that mission scientists needed a way to keep track of them all. So, in the early 2000s, they launched what is now become known as the NASA Sun-Grazer project, which allows citizen scientists to report comets when they find them in Soho images. Soho's 5,000th comet was found by Hanji Tan, a sun-grazer project participant originally from Guangzhou in China and currently pursuing his PhD in astronomy in Prague. Tan's been participating in the sun-grazer project since he was 13, and he's discovered more than 200 comets since 2009. Number 5000 was a small chunk of ice and rock belonging to the Marsden group of comets, which only take a few years to orbit the Sun. Now, this group are thought to be related to the comet 96P Machholz, which passes near the Sun every 5.3 years. Only about 75 of the 5,000 comets discovered by Soho so far belong to the Marsden group. Sun-Grazer Project Principal Investigator Carl Badams from the U.S. Naval Research Lab in Washington, D.C., says that prior to the launch of the Soho mission and the Sun-Grazer project, there were only a couple of dozen sun-grazing comets on record. The vast number of comets discovered using Soho has allowed scientists to learn more about sun-grazing comets and groups of comets that orbit the Sun. Comets discovered by the Sun-Grazer project have also helped scientists learn more about the Sun itself by watching the comets plunge through the Sun's atmosphere like small solar probes. Badams says the statistics of 5,000 comets and looking at their orbits and trajectories through space has provided a unique data set.
When I began with the Sun-Grazer project, we had less than 1,000 comets. That was over 20 years ago. So the fact that we've finally reached this milestone, 5,000 comets, it's just unbelievable to me. Sun-Grazer project is a project that allows anyone, anywhere in the world to sit down with a laptop and discover comets. The clue to what a sun-grazing comet is kind of in the name there. It's literally a comet that grazes by the Sun. The Sun-Grazer project relies exclusively on images of the Sun from spacecraft, and the images that we discover nearly all of our comets in come from the Solar and Heliospheric Observatory, or Soho. That is a satellite that was launched in 1995, so it's been operating for a long time now.
3, 2, 1, ignition, and liftoff of Soho and the Atlas vehicle on an international mission of solar physics.
Our participants go to the Soho website where we have all of our latest images from the spacecraft, and they download those images, and it's really as simple as looking through them, flicking through the image, and looking for something tiny and faint and moving in a different direction to the stars. Discovering a comet is a very unique feeling. You have this realization that suddenly you've found a piece of the solar system, a piece of the universe that no one has ever seen before. Prior to the launch of the Soho mission and the Sun-Grazer project, there were only a couple of dozen sun-grazing comets on record. That's all we knew existed. The 5,000 comet milestone is a huge achievement. It's one that none of us dreamed we would even get to. So simply the statistics of 5,000 comets and looking at their orbits and trajectories through space is a super unique data set. It's a really valuable science, and it is just a testament to the countless hours the project participants have put into this. We absolutely would not, under any circumstance, be here if it wasn't for what our project volunteers have done. That's really what 5,000 comets represents. It's 20 or more years of invaluable discoveries from the project volunteers.
That's Sun-Grazer Project Principal Investigator Carl Badams. And this is Space Time. Still to come, Soyuz returns to Russia with love, and later in the science report, a new study shows that young people with mood disorders are less likely to get their driver's licenses early and more likely to crash when they do get them. All that and more still to come on Space Time. Russia's Soyuz MS-24 capsule has returned safely to Earth, landing under blue skies on the Kazakhstan steppe. The Roscosmos MS-24 mission touched down near the Kazakh city of Zhezkazgan. The spacecraft had undocked just hours earlier from the International Space Station. The mission carried a NASA astronaut who had spent the last 6 months on station. Also aboard were a Russian cosmonaut and the first ever Belarusian cosmonaut, both of whom had flown up 2 weeks earlier aboard the Soyuz MS-25 mission.
Preparing to depart are NASA's Laurel O'Hara, Oleg Novitsky, the Soyuz commander, and Belarusian spaceflight participant Marina Vasilevskaya. Novitsky and Vasilevskaya completing 14 days in space, having launched on March 23rd on the Soyuz MS-25 spacecraft, along with NASA's Tracy Dyson, who is well now into her 6-month mission aboard the International Space Station. O'Hara is completing 204 days in space, a mission spanning 3,264 orbits of the Earth and 86.5 million miles. The actual transition, the formal transition of Expedition 70 to Expedition 71 on board the International Space Station begins at the time of undocking. Expedition 71 will be led by the current station commander, Oleg Kononenko, who has spent more days in space than any other human. As we prepare to see the 3 returning crew members enter the Soyuz, the report back from the Russian Mission Control Center in Korolyov is that Soyuz has been transitioned to autonomous power. A final wave from Vasilevskaya and O'Hara, and now Novitsky on board the Soyuz, having bid farewell to their expedition colleagues. The International Space Station currently flying 260 miles over Osaka, Japan. The hatch closed on the Rosviet module side. They will be standing by for confirmation of the Soyuz hatch closure.
Moscow Station on space to ground 1. Go ahead on space to ground 1. The station hatch is closed. Oleg, copy all. We saw it all. Thank you. Everything is great.
And we now have confirmation that the Soyuz hatch has been closed at 7:45 p.m. Central Time, 8:45 p.m. Eastern Time. So hatches on both sides of the docking interface between Rosviet and the Soyuz MS-24. Both of those hatches are closed right on time as the crew now on the Soyuz side, as well as the station crew, will begin a series of leak checks at the docking interface to make sure we have a tight seal before the passageway or small vestibule between the 2 spacecraft is depressurized in preparation for undocking.
Copy.
All of the Soyuz systems in good shape as we are about to embark on the departure of the Soyuz MS-24 from the Rosviet module, beginning the journey home for NASA's Laurel O'Hara, Roscosmos Soyuz commander Oleg Novitsky, and Belarus spaceflight participant Marina Vasilevskaya. Undocking confirmed right on time at 10:54 p.m. Central Time, 11:54 p.m. Eastern Time. Soyuz MS-24 has broken free from its mooring at the International Space Station. Expedition 70 is complete. Expedition 71 now underway.
Copy. Observing the docking port, there are no extraneous items.
Soyuz MS-24 now undocked from the International Space Station. The undocking occurring 260 miles over southern Mongolia. All of the Soyuz systems in good shape, very stable. That center section of the Soyuz is where the crew is strapped into their seats. You'll hear the Russian controllers talking to Novitsky from time to time, referencing the call sign Kazbeki. Each Soyuz commander names their craft after a call sign, in this case, a favorite mountain range of Novitsky's.
Join the GSO, confirmed. Copy, stand by for the second burn. Copy.
That second separation burn, referred to there by the Russian flight controllers through an interpreter, is a 15-second burn.
Thruster ignition.
Separation burn number 2 underway.
Thrusters are off. Copy. Let's put in the V-18 command and turn off Vizir Prichal.
And a good pair of separation burns for the Soyuz, now well underway, backing away in increasing velocity from the International Space Station. Just about 2 hours and 11 minutes away from the deorbit burn that will set the stage for the Soyuz descent module's entry back into the Earth's atmosphere and a landing on the steppe of Kazakhstan at 2:17 a.m. Central Time, 3:17 a.m. Eastern Time. At the landing site southeast of Zhezkazgan, it's a beautiful Saturday afternoon with just a few clouds at 10,000 feet, winds out of the southwest at about 6 knots, and the temperature expected to be around 60 degrees Fahrenheit for a balmy spring return to Earth. We're standing by for visual confirmation from the search and recovery forces that the Soyuz is now descending under its parachute. The Soyuz, under its main chute, white vapor is the combination of hydrogen peroxide and oxygen being vented from the life support system tank. That is nominal. Time to touchdown, 11 minutes, 40 seconds. The large orange and white chute is fully reefed. The Soyuz descending at a nominal rate, visual contact from the search and recovery forces. The Soyuz descending under its chute, the heat shield has been jettisoned. That is a radio beacon signal from the Soyuz, used for tracking purposes for the search and recovery forces. Just over a minute until touchdown, 600 meters off the ground.
Космос 906. Группе 4 единицы подходим к объекту. Берем на сопровождение.
4 units are approaching the object. I can see the ground now. The altitude is 500 meters.
One of the Russian Mi-8 helicopters circling the vicinity, another one. Once the Soyuz touches down, so will those helos in sequential fashion
350.
to begin the heart of the extraction process as they remove the crew from the descent module.
All right, we will be keeping silent here and waiting for the landing.
And we have touchdown. Touchdown at 2:17 a.m. Central Time, 3:17 a.m. Eastern Time, 12:17 p.m. at the landing site. Laurel O'Hara back on terra firma after 204 days in space.
This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Up to 70% of the world's wine-growing regions, including those in Australia, could be at risk if global temperatures increase beyond 2 degrees Celsius. The findings, reported in the journal Nature Reviews Earth and Environment, suggest that climate change in Australia will lead to overall warmer and drier conditions. That means that traditionally suitable inland regions might become unsuitable for growing, especially in New South Wales. Though it's not all doom and gloom in the south for the Oceania region, the researchers say that Tasmanian and New Zealand wines might end up seeing boosts in their wine production under the increased heat predictions. A new study has found that young people with a mood disorder are less likely to get their driver's licenses when they become eligible and more likely to crash when they do start driving. The findings, reported in the Journal of the American Medical Association, looked at driver's license rates and driving outcomes among a group of 1,879 teens with a mood disorder and about 85,000 without a mood disorder, all at around the age when they became eligible to drive. The researchers say young people were 30% less likely to get a driver's license if they had a mood disorder, and those with mood disorders who did get a license had a higher likelihood of crashing within the first 2 years compared to their peers. A new analysis of existing studies has confirmed that drinking 100% pure fruit juice is linked to a weight gain in children. A report in the Journal of the American Medical Association found that just 1 serving per day of 100% fruit juice was linked to a body mass index gain among children. In adults, the study also found a link. However, this link disappeared when they adjusted the data to account for total energy intake. That suggests that it is the extra energy or calories found in fruit juice which is producing the effect. The researchers say their findings support recommendations to limit the consumption of fruit juice to prevent the intake of excess calories and weight gain. Well, it seems Harvard astronomy R.V. Loeb's at it again. This time he's suggesting that meteor impact ejecta from an asteroid which crashed into the ocean north of Australia could actually be alien technology designed to seed the planet with life from another world beyond our solar system. However, while we do occasionally find meteorites containing material from beyond our solar system, it's not that uncommon. An analysis of this particular debris sample, and in particular objects known as spherules, shows that there's nothing interstellar about their chemical makeup or composition. In fact, Tim Mendham from Australian Skeptics says, in this case, the fragments could even have been formed from the Earth itself.
Yeah, Avi Loeb is a Harvard astronomer. He has been involved in many sort of quite significant developments in astronomy and in astrophysics. So he's no outsider to this area. So he has the name, the reputation, but over the years he's been making claims that are sort of very strange. Initially, one particular claim he made was that a meteorite crashed into the water in an area called the Australasian Tektite-strewn field. Now, the Australasian Tektite-strewn field covers most of Australia and up north and northwest up through New Guinea, Indonesia, up into Southeast Asia. And supposedly what they have discovered is on the ocean floor is little tiny spherules, which are very, very small, sort of millimetres in size.
And these are common from meteor impacts. This is a regular byproduct. There's also glasses that can be created this way. So the spherules themselves aren't unique to this particular impact site.
No, but what has happened here is the claims that Loeb has associated with them. Now, one, he's saying that this is a meteorite that came from interstellar space, so from outside the solar system, and his evidence for this is supposedly the chemical composition of these spherules. And people have assessed them and said, no, they're pretty ordinary spherules that could definitely come from within the solar system, from a normal meteor you find in the solar system. It could also just come from the Earth, because some of the elements that are in there, or the composition, the makeup of the elements, especially iron isotopes, the ratio of those is very earthly. Also, his ability to predict where this meteor that supposedly crashed in 2014, I think it was based on one sensor picking up some information. And if anyone who does surveying knows, having one sensor is not actually very good. You can't triangulate.
I was going to say, it's not a way to triangulate.
Yeah, no, you can't triangulate with one sensor. You just know roughly in the direction it was and you try and estimate how far away it was. What some researchers found out, that highly likely the sensor reading that he was basing his whole theory on was a truck driving past, and that therefore relying on one sensor is not very good. Now, all that would be good, fine, okay, the spherules have been found in this field, which might come from space, might be a long time ago, but what he is now saying, he's sort of adding this value add to his theory that they're actually alien technology and that an actual extraterrestrial life that is firing this stuff at us in what can be described as directed panspermia, and that's one of the aspects that he's been talking about spreading life out into the universe by firing biological material, and he's suggesting that this might be coming the other way from outer space. So it's alien tech coming from outside of the solar system being directly fired at Earth, and this is the evidence of it. So from his spherules that may or may not be extraterrestrial, he's gone to finding a particular meteorite, the evidence of it, uncertain, both of those are uncertain, and takes it one step further and saying this is actually manufactured technology being fired by aliens. And that is sort of surprisingly well, perhaps not surprisingly, raised the concern of a lot of people out there who are suggesting that perhaps he's stepping outside of his areas of expertise a little bit, even though he has been a very successful astronomer and a theorist and practical as well on astronomical, astroscience areas.
Avi's also been really big on the idea that the interstellar asteroid that did come from beyond our solar system and went away again, that could have been an alien spacecraft.
This is the
Oumuamua, yeah.
I always say Oumuamua, yes, that everyone thinks it's probably natural.
Yeah, it was natural. It was just gases changing the course of the asteroid as it moved away from the solar system. It's quite natural.
But there's a lot of people who actually sort of claim that one as being extraterrestrial. So Avi Loeb is obviously picking up on those theories as well.
I think he might have started it, actually.
It is a shame.
Is this a form of Nobel syndrome?
I think it is. I think it is very much. Sort of what happens is that, and we've published information on this on Nobel Prize winners who have been recognised for activities in their field, genuine activities, very praiseworthy activities, won the Nobel Prize, and then somehow figure out that because they've won the Nobel Prize, anything they say must be correct.
The font of all knowledge.
And that's right. And they move into other areas which are outside their areas of expertise for which they won the Nobel Prize, and then they start pontificating on other things. And then, of course, all the followers will say, look, Nobel Prize winner, here's your scientist who is actually proving this thing. But you say, but he's not the right sort of scientist. This is not his area. Because the community be out there which will pick up on anybody who has a fringe belief that supports their fringe belief. And they often say science is untrustworthy apart from my pet scientist.
It's like the Australian geologist who claims that global warming isn't real, and he must be right because he's a scientist. But he's a geologist. He's not a climatologist or meteorologist.
That's
so
right.
He's looking
There's
at the
a lot of
past,
people
and he's
I know.
not looking at the present situation.
That's right. I mean, yes, anything that happened sort of eons ago, it's not necessarily applicable now, especially in the time frames that we're talking about.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.